Okay, you've totally been there, right? You spend all this time carefully picking out stuff for your online shopping cart, you click to the next page, and poof, it's empty. That is so frustrating. And it's actually a failure of something called session management. So today, we're going to pull back the curtain on how massive websites solve this invisible but absolutely crucial challenge to keep your experience smooth, even when millions of other people are online at the exact same time. That moment, when your cart just empties itself or you get logged out of an app for no reason, that's our starting point. The magic that keeps that from happening is what we call a user session. But how on earth do you keep that magic alive when your website is dealing with traffic from millions of people spread out across like a whole farm of servers? That's the big question, and that's what we're going to unpack. So to really get a handle on the problem, we have to start at the beginning. Let's rewind to a much simpler time. We'll call this Act 1, the simple world. This is a world where our app is just living its best life on one single server. So what is a user session really? Well, think of it like this. It's like a temporary cubbyhole that the server sets aside just for you. When you log in or add something to your cart, the server just pops that info into your personal cubby. The next time you click on something, it knows exactly where to look to remember who you are and what you were doing. Pretty simple, right? And in this simple world with just one server, it's honestly a piece of cake. All the cubbyholes, all the user sessions, they're all stored right there in that one server's memory. So every single request you make goes to the exact same machine, and that machine instantly knows all about you. Life is good. But then, something happens. It's a wonderful thing, but also a terrible thing. Your app gets popular. It's a hit. And that brings us right into Act 2, the scaling problem. See, success brings its own set of headaches. Our one lonely server just can't handle it anymore. It's getting absolutely swamped with requests from thousands, maybe even millions of users. The pages start to load super slowly, things begin to break, and our users, they're getting really annoyed. We've got to find a way to handle all this new traffic. So what's the standard solution? We scale out, or what engineers call scaling horizontally. Instead of trying to build one super powerful server, we just add a bunch more. And to manage all of them, we put a load balancer out in front. You can think of it like a traffic cop, directing all the incoming user requests to whichever server seems the least busy. That way, no single server gets totally overwhelmed. And here it is. This is the absolute heart of the problem. Your very first click goes to server A. Server A is great. It creates your session, your little cubbyhole with all your shopping cart info. But then your next click gets sent by our friendly traffic cop, the load balancer, over to server B. Server B goes looking for your cubbyhole, and it finds nothing. It has no idea who you are. As far as server B is concerned, you're a complete stranger. Your shopping cart is empty. You're logged out. This right here is the session consistency problem. Okay, so how do we fix this mess? Let's take a look at our first option, what we'll call Path 1, sticky sessions. This is usually the first thing people try, mostly because it's the most direct and, well, obvious approach. The idea behind sticky sessions is pretty simple. We basically just tell the traffic cop, our load balancer, hey, once you send a user to server A, you have to make sure that all of their future requests also go to server A. That's it. The session sticks to that one server. It feels like an easy fix, right? But there's a pretty big catch. So the big advantage here is just how simple it is. But the drawbacks, they're pretty serious. What happens if server A goes down? Every single user session on that machine is gone. Just poof, instantly lost. On top of that, it really handcuffs the load balancer. It can't do its main job, which is to efficiently spread out the traffic. It's stuck sending people back to the same machine, even if that machine is getting totally overloaded. So, all of that leads us to a much more robust and modern approach. Let's call this Path 2, centralized storage. The idea here is, instead of keeping the cubbyholes inside each individual server, we're going to build one giant central closet for them. With this setup, it literally does not matter which server your request hits. Server A, server B, C, or Z. They all know exactly where to look for the session data, a shared central store. Usually this is a super fast in-memory database like Redis. So server A can create the session, and then when your next request hits server B just asks the central store, hey, what's this group on this user, and gets all the info it needs instantly. And this is the real power of decoupling things. our application servers become stateless, which is a fancy way of saying they don't have to remember any user-specific data themselves. This gives us amazing reliability and scalability. If a server fails, no big deal. No sessions are lost. The load balancer just sends the user to another server, and that new server picks up right where the last one left off. The main drawback? It adds a tiny bit of latency, a few milliseconds, because each request has to make a quick network trip to that central store. All right, so we've got two pretty different ways of thinking about this on the server side. But believe it or not, there's actually a third approach that just flips the whole problem on its head. Let's take a quick look at that one before we compare all three and start thinking like a real system architect. This third path is to store the session data on the client side. That means it lives right inside the user's web browser, usually in something called a cookie. With this model, the server doesn't have to remember anything at all. The user's browser is responsible for sending all the session data back to the server with every single request. The trade-offs here are pretty obvious. Cookies can only hold a very small amount of data, and you have to be extremely careful about not putting sensitive information in there because of security risks. So if we lay it all out, you can see the trade-offs crystal clear. If all you care about is raw performance, sticky and client-side sessions are the fastest since there's no extra network call. But when you start talking about scalability and reliability, the things that are the bedrock of a massive application, well, centralized storage is the undisputed champion. Sticky sessions are simple, but they're fragile. Centralized storage is more complex to set up, but it's incredibly robust. And client-side sessions, well, they trade server load for some pretty significant security concerns. And this brings us to the most crucial point of all. In system design, it is always, always about trade-offs. There is no magic bullet, no single best solution. Sticky sessions might be perfectly fine for a small internal company tool where simplicity is more important than 100% uptime. A high-security banking app would probably never, ever put session data in a client-side cookie. And a huge e-commerce site like Amazon, you can bet they're going with centralized storage because for them, making sure your shopping cart is reliable is a core business need, and that's worth way more than a few milliseconds of latency. And so that leaves us with one final question for you to think about. Your app just blew up. It's a huge success. You're facing the scaling problem right now. Looking at all the trade-offs we just talked about, what's your first move? Are you going to go for the quick and easy fix with sticky sessions just to stop the bleeding? Or are you going to invest the time and effort to build a super robust centralized system that's built for the long haul? The choice is yours.